All right, 6.6. For this lesson, we're going to use what's called the rational root theorem to find all possible solutions of a polynomial. Okay, so rational root theorem, it gives if this polynomial has integer coefficients, then every rational zero of f has the following form. Okay, so what this boils down to is you're going to figure out the factors of the constant term. Okay, the constant term is always just that number, and then that's going to go over the factors of the leading coefficient. Okay, once we do an example here, it'll be a little more easy to see. So again, the big thing, it's always the factors of the constant over the factors of the leading coefficient. Okay, so in this case, if we're looking for the possible rational zeros of the function f of x equals x cubed minus x squared minus 9x plus 9, all we're looking at is those two terms. So if it's in standard form, you're looking on the outsides of the function. Okay, so again, the numerator is the factors of the constant, okay, which we consider p. Okay, factors of the constant are p, and those are going to be our factors in 9. So 9, our factors for 9 are 1 times 9, so that's 1 and 9. 3 times 3, so our factors in 9 are 1, 3, and 9. Okay, and then factors of our leading coefficient, again, are just 1, because our leading coefficient was 1. So again, there's p, there's q, and it's always p over q. So in this case, we got 1, 3, 9 over 1. And what we're going to do is we're going to take every possible combination. Okay, so 1 over 1, 3 over 1, 9 over 1. And that's what we have for this case. So our possible roots in this case, again, 1 over 1. And they will always be plus or minus. Okay, and then plus or minus 3 over 1, and then plus or minus 9 over 1. Now let's go ahead, let's simplify those. 1 over 1 is 1, 3 over 1 is 3, 9 over 1 is 9. So our possible solutions for this polynomial would be plus or minus 1, plus or minus 3, and plus or minus 9. Okay, so when it comes to finding possible rational zeros, it's the factors of the constant over the factors of the leading coefficient, and you're taking every combination possible. Okay, so let's go ahead and do another example. So again, we're looking at just the constant and the leading coefficient. And since it's the leading coefficient, we need to make sure it is in standard form, which it is. So we're looking here and here. Okay, so again, p over q. P being the factors of the constant, which is 6. So my factors of 6 are 1, 2, 3, and 6. 1 times 6 is 6, 2 times 3 is 6, so those are my factors. And then again, q are factors of the leading coefficient, which is 1 in this case, so just 1. So listing out those possible solutions again, doing every possible combination of those. So we got 1 over 1, 2 over 1, 3 over 1, 6 over 1. And again, it's the positive and the negative of that combination, so plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay. Now, in this one, it said find all zeros of it. Now, we could take those and we can plug those in, use synthetic division to see which one of those works. Okay. So, for example, we can take it, do our synthetic division, and it's x cubed, so 1, negative 7, 10, and 6. It's a cubic function, so we should have 4 coefficients. And then you can just start working through those possible solutions. We said positive 1's a possible solution. So you drop it down, 1 times 1 is 1, add, multiply, add, multiply, add. Okay, right there, since we got 10 there, that tells us that that is not a solution. So then you'd start over, And you could use negative 1, 1, negative 1, negative 8, positive 8, 18, negative 18, and that does not get you 0 again. Okay, so that would be a long process to do that. Luckily, in today's day and age, we have the calculators, so we can go to the calculator and find those zeros that way. Okay, now let's go ahead. Let's plug that into the calculator. Again, when we do that, we go to y equals. And we're going to plug in the function. We got x cubed minus 7x squared plus 10x plus 6. Now, when I hit graph, what I'm going to go to is I'm going to look for plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, when I look at the graph now, I see that it looks like it goes through 3. Okay, so if we were to go and use 3 in this, 1, and then we're going to multiply, add, multiply, add, multiply, add. Right there we confirmed that 3 was a 0. Okay, so 3, and again from there, now when we did that synthetic division, we got it to 1 degree less, because again, remainder, constant, linear term, quadratic term, x squared minus 4x minus 2 is equal to 0. Then we can use one of our methods of solving a quadratic to find those other two zeros. Okay. So really what it boils down to is this is the method that they used way back when, before they had these nice calculators, and they had to go through every single one of those combinations in order to find one of those zeros, to get to one of those lower degree polynomials so that they can solve a quadratic, or, you know, if it was a cubic, if it was four terms. Okay, but luckily today we have the calculators, and we can just use those possible zeros to help us find them on the calculator. Okay, like we said, we went to the calculator, found that 3 was a 0. All right, so here now, make sure that it's in standard form. Look at our leading coefficient. Okay, P over Q again. P is the factors of the constant, so which is 12. 1 times 12 is 12, so 1 and 12. 2 times 6. 3 times 4. Okay, and our factors of the leading coefficient, which are just 1. So our possible roots: 1 over 1, 2 over 1, 3 over 1, plus or minus 4, plus or minus 6, plus or minus 12. So you can imagine back in the day, if they were trying to solve this polynomial, they would have to do that synthetic division with all of those until they found the zeros, and then work from there. Again, we're not in that age. We have our calculators to help us find those zeros. All right, so here, let's go ahead. P over Q again. Factors of the constant are just 1. Factors of the leading coefficient, which is 2, 1 over 2. So our possible roots are 1 over 1, so 1, and then plus or minus 1 over 2. Okay. So again, when I'm asking for just possible rational zeros, I'm asking you to use this rational root theorem to give me those plus or minus values. All right. Let's go ahead. Let's do one more. Let's do f of x equals 4x to the 4th plus 2x squared plus 6. Okay, so again, P over Q. P is my factors and my constant. So 1, 2, 3, and 6. Those are my factors of 6. My factors of 4 would be 1, 2, and 4. Okay, so again, every single combination. So it's going to get a little longer on this one because I have to take 1, 2, 3, and 6 with 1. And when I do that, it's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, that's me working with that 1 through. Okay, but now We finished with that 1. Now we need to go with the 2. So plus or minus 1/2, plus or minus 2 over 2, which is 1. Okay, I already have that with this one, so I'm not even going to worry about writing that one. We do not need to repeat ourselves. So then we got plus or minus 3/2. Okay, and then finally plus or minus 6/2, which would be 3, which we already have that one as well. Okay, so I worked through the 2, and then finally with that 4, plus or minus 1/4, plus or minus 2 over 4, which is 1/2, which we already have right here, so I'm not going to rewrite that one, plus or minus 3/4, and then finally plus or minus that 6/4, which is 3/2, which again, we do not need to write since we already have that one. Okay, so you can imagine if they were solving this one, this would be a real fun one to work with, because then they have 4, 6, 8, 16 possible rational zeros that they would have to check and then work from there. So luckily in this day and age we have our calculators, and this can just be a guide for us on the calculator. All right, so your assignment for this lesson then, 6.6, okay, listing possible rational zeros and listing all of those zeros, the P over Q. So again, the factors of your constant over the factors of your leading coefficient. Okay, and then we got some actual solving by finding all the zeros. Okay, so there you're going to use your calculator, find those zeros, use that rational root theorem to help you guide you on your calculator, and then find all the zeros again. Okay, so if you have questions, make sure you ask those. Otherwise, have a good day.